Okay, so here we're told we have this tree right here, and you can see that this tree is forming a shadow. So they're focusing on this tree right here, I guess representing the leg of a right triangle. And here's the shadow right down here, and we're told that this shadow is 25 feet long, right, on a sunny day. So we're going to assume it's 25 feet long. And the angle of elevation from the tip of the shadow to the top of the tree is 32 degrees. So they label this angle right here, right? They're referring to this angle. And they want to know what's the height of the tree. So to the nearest tenth of a foot. So what can we do here, right, to solve it? And this is a little bit trickier than maybe some other ratios. But maybe what I'll do is I'll say that, if we have this angle and we have our trig ratios of SOHCAHTOA, we want to think about the fact that the two options we really have are cosine and tangent, because sine involves the opposite from the angle you have over the hypotenuse. And you could find the other angle up here and then use that because you would have the opposite. But from this angle perspective, we don't have either opposite from the angle, we don't know that length, and we don't know the hypotenuse. So I'm not going to use sine. I'm going to probably use cosine here because it's just the next one, and it includes adjacent in its ratio. Remember that the cosine of theta, that means the cosine of any angle you're looking at, is equal to the ratio of the adjacent side to the angle you're at over the hypotenuse. So we have the adjacent and we have the angle measure. We just don't have the length of the hypotenuse, and that'll help us because once we have, well, you know what? Actually, cosine is not the best choice. Sorry. I'm thinking, if we use this ratio, we can find the hypotenuse, but they don't want to know the hypotenuse. They want to know the length of the tree, which is the other leg right here. And that being said, I think tangent is the most useful because tangent equals, tangent of 32 degrees is going to be equal to, look at a ratio here, TOA, opposite, that's the tree length, over adjacent, which is 25. So you can always see that we have 2 out of the 3 terms, so we can use this to find the opposite. So what I do is I then take the tangent of 32 degrees. That's this long decimal right here. But I know from algebra, right, if I had, let's say, 5 equals x over 25. Well, to find what x is, I would multiply both sides by 25, right? So 25 here and 25 here. On the right-hand side, they cancel out, and 5 times 25 is 125, and that would be x. We can do the same thing here. We can multiply both sides by 25. It cancels out and cancels out. And over here, we can do 25 times 30, tangent of 32. We already have the tangent of 32 here, this long decimal. Just multiply it by 25. So here that means that the height of the tree is about 15.62, and they want to know to the nearest tenth of a foot, so that's 15.6 feet tall. That's how the height of this tree. Oh, and here's the answer here too. Thanks.